Hello, how are you? Hello, how are you? Are you fine? Are you there? Can you hear me? Hello, Miguel, stay focused. Hello, Sandra, Rodri, Julia, are you there? Can you hear me? Okay, we're going to start. So maybe you can't see me, but that's not important. So the important thing is that we are very near the end of this course, but the end of this course is on Friday. Today we're going to work, and we're going to work with decision. Okay, so pay attention. All you have to have before you is your notes, your natural science notes. We're going to study about static electricity, and now you have your notes there, and remember page number 4, and remember we are going to study some exercises you did the other day. So let's get started. Hello, Eneko. So please stay focused. So static electricity, and you remember that electricity is a kind of energy that is based on the flow of electrons, because you know that all matter is made up of atoms, and atoms are composed of some tiny particles. Some of them are electrons. These particles that are negatively charged are electrons, and these positively charged are protons. You know that. So static electricity is the stored form of electricity. You know that. And in this text you can read most objects have a balance of positive and negative charge, so they are considered neutral. This means that they do not push or pull on each other electrically. Why? Because all matter tends to balance, so all matter is neutral. However, sometimes electrons can build up in an object. Two such objects can push or pull on each other because they are no longer neutral. So imagine you have here this balloon, you wrap this balloon, and you can get these electrons here in this way, and here you have a wall, and this negative charge attract to this positive charge, and this positive charge repel this other positive charge you can see in this other balloon. So, and this push or pull from extra electrons is called static electricity. And you have here a photo. This girl, you can see her with her hair on end, and these hairs are attracted by these balloons. So the explanation is based on static electricity. So static electricity can cause interesting effects such as sparks or lightning bolts. Sparks son chisporroteos, or lightning bolts. These are what in Spanish we call relámpagos. When it's released, sometimes the extra electrons build up by rubbing one object against another. For example, when one rubs a balloon against one's hair, electrons move from the balloon to the hair. Because the hairs then all have extra electrons, which all have the same kind of charge, they try to fly away from each other and end up sticking into the air like spikes. Okay, so with that in mind, I'd like you to watch some video clips about static electricity. So pay attention, because this is the first of our
Hay un orangután en mi cuarto y no sé qué puedo hacer. Ha cogido mis juguetes.
Hello, friends. Today we'll learn about static electricity. Ah, I see you're very excited. It is the buildup of an electrical charge on the surface of any object. The charges remain in one area, then moving to any other area.
So we have charge, an electrical charge in an area, and that charge moves to another different area. Remember that.
So it's called static. In other words, we can say static electricity occurs when there is an imbalance of positively and negatively charged atoms.
An imbalance in Spanish es un desequilibrio, because we have more positive charges than negative ones, or the other way around.
It was discovered accidentally and was investigated by the Dutch physicist Peter van Musschenbroek and independently by the German inventor Edvald Georg van Kleist in 1745. You must have experienced the effects of static electricity. Remember when you had a bad hair day? This is the effect of static electricity that has built up on your head.
Okay, these hairs are proof of the proof of an example of static electricity.
It happens because of the basic building blocks of all matter, called atoms. All materials are made up of atoms. Atoms can...
Remember that. This, you know all about that. This is an atom, this is a nucleus, and these are the shells or the orbits. These blue particles are electrons. And here in the nucleus you have green particles and pink particles. One of them are protons and the other are neutrons. If you have 3, 4, 5, 6, 7, 8, you have 8 electrons, you need 8 protons. Why? Because you need the atom to be neutral.
Contain even tinier particles known as electrons that carry a minus or negative electrical charge.
Remember, electrons are negatively charged. Remember that. This is important. And they are moving. They are spinning round and round the nucleus of the atom. Remember that.
Electrons orbit a positively charged nucleus. The surface of some objects, such as the balloons, steal electrons from other surfaces, and the extra electrons make them negatively charged. When electrons build up with no circuit for them to flow along, they create...
Okay, so pay attention to this. These are different substances, and here you have the image of an atom. And spinning round the atom, round the nucleus of the atom, there are these blue particles that are electrons. Remember that electrons are negatively charged. And here you have another different substance with some positive and negative charge. Okay, they are all in all in balance. They are in a balance. They have imbalance. But maybe one of these electrons can move to another different object. And in this case, we have an imbalanced.
Non-moving or static electricity. Let's understand this with a simple experiment. See this man walking on the carpet? This carpet is covered with many electrons. As he walks, he picks up the static electricity. When they shake hands, the electricity discharges through the lady, giving her a sudden shock. Let's see the uses of static electricity. Static electricity is used in electrostatic precipitator. A photocopier also uses this electricity. Inkjet and laser printers use static electricity to guide a small jet of ink to the appropriate place on the page.
Okay. So there are many appliances that use static electricity. So printers to make photocopies, many things that are based on this phenomenon.
But there are some dangers associated with static electricity. Most gasoline container refueling fires are due to static electricity. And
okay, so when these wheels are ramming the pavement, they are positively or negatively charged, and this can be very dangerous, as you are going to see now.
They're caused by the container not being filled on the ground, but in the trunk of a car, the back of the truck, or the step of a van. If static charges are allowed to discharge through the areas where there is petrol vapor, a fire can occur.
So, really dangerous.
Lightning is also static electricity. Heavier, negatively charged particles sink to the bottom of the cloud. When the positive and negative charges grow large enough, a giant spark, lightning, occurs between the two charges.
This is the base of this spark, lightning, relámpago. This is based on static electricity.
Now, you know a lot about static electricity. Please drop a like, leave a comment, share the video.
Okay, so very good. Now, this is the first of our video clips today, and I like you to watch another different video clip. This is interesting because talking about exploring static electricity, and this is a video clip with some experiments. Pay attention to it.
Hi, I'm Jared. Welcome to Fun Science Demos. Check this out.
Oh, looks like magic, but it's not. Okay, this is not. This is science.
How did I do that? What was going on there? Was it magic? No, it was science. Well, what you didn't see me do was rub this straw on this fur and charge it up. Well, what do I mean when I say charge it up? Well, through science, we've discovered that all matter is made of positive and negative charges. And sometimes, some of that matter, we can actually rub off only the negative charges. And that allows us to do some really interesting things. Remember, by me rubbing this straw on this fur, I'm putting more negative charges on the straw.
Easy. You can do it at home. You rub your, I don't know, your pen, not your pencil or your pen, something that is made of plastic. You can take away some negative charges, or maybe you can add up some negative charges. And in this case, this plastic stick can be electrically charged. And with that, you can make many things that look like magic, but this is science.
And through science, we've discovered that positive and negative charges attract. They come together. Think of it like this. When the charges are different, they want to come together. But when the charges are the same, they want to push apart.
This is important. So, like charges repel, and like charges attract. Remember. Sorry.
And scientists call that static electricity. So now let's take a look at this. So I have a can, and remember we said that all matter is made of positive and negative charges. This can is not charged, so it's made of positive and negative charges. Now watch what I do here. I'm going to rub this balloon on the same fur that I rubbed the straw on, and it's going to pick up a whole lot of extra negative charges. What do you think's going to happen when I take this balloon and put it toward the can? Will the can push away, or will the can roll toward the balloon? Let's take a look and find out. Here we go. Negative charges on the balloon. The can is made of positive and negative charges.
So, if here we have negative charges, in this can we have positive one, and this is the reason why they attract each other. This is not magic. This is science.
What just happened there? The positive charges on this can were attracted to the lots of negative charges on this balloon. Let's see if we can do that again and see how fast we can get this can going, maybe race it off the table. Can races with static electricity. So remember we said all matter is made of positive and negative charges, and that all.
So, this is another experiment. This is another experiment with water that can be charged equally.
Also holds true for liquid matter. Here I have a container of water and I have a cup with a hole punched in the bottom. I'm going to fill this cup with water, hold it up and let the water drip out the bottom of the cup, and then hold my balloon up to that stream of water. Let's see what happens. is the water going to be pushed away from the balloon, or is it going to be pulled toward the balloon? So now I'm going to rub the balloon and charge it up with lots of negative charges. Hold up my cup, and you can see.
Can you see? Can you see? This is the flow of water, and it's attracted to the balloon. Why? Because the balloon is positive or negatively charged, and that attracts this flow of water.
See, the water is pulled toward the balloon. So what does that mean? Well, I had a lot of extra negative charges on here. What kind of charges attract? Well, opposite charges attract. So that means this water must have lots of positive charges. So what does that mean? That means as I rub the balloon on the fur and I charge it with lots of extra negative charges, if that water is pulled toward the balloon, that water must have positive charges in it. So we know that balloons can pick up extra negative charges, but I have to wonder, can other things pick up extra negative charges?
Okay, so this is another experiment. So you have here this kind of wool fabric. This is a comb, this is a fork, and this is a plastic bat. So pay attention. Here you have a lot of tiny papers, confetti. Pay attention.
So to test this out, we have lines of just torn up little paper called confetti. I have a comb, a plastic fork, and a plastic bat. And instead of using fur, we're going to try using wool, just wool fabric. So let's check it out. Let's start with the comb. Pick the comb up. I'm going to rub the comb on the wool, charging it up with extra negative charges. What do you think is going to happen when I pass it over the torn up pieces of paper? It's kind of jumping onto the comb, but is it really jumping? No. Positive and negative charges attract. It worked okay. Let's try the fork. Charge it up with lots of extra negative charges. Pass the fork over.
Can you see?
And you can see a few bits of paper are attracted to the negative charges. Now let's try the plastic bat. We charge it up, and you can actually hear and see the paper stand on end as I wave it over, and it jumps right onto the bat. It didn't jump. The positive and negative charges were attracted to each other.
It looks like magic, but this is not. Okay, this is science. Remember that? And this is the last experiment.
So finally, take a look at this game that we made up using static electricity. We call it Sharks and Minnows.
These are sharks, and this little fish here is a minnows. A minnow is a little fish that can be found in a river or a lake. So this is a little fish, and these are sharks. Pay attention.
I have some sharks made of tissue paper hanging from this crate. You could hang them from your desk and let them drape down toward the floor. And then I have a little dish of what I call fish food. It's just the confetti we used in the other demonstration. And then I took the straw we used from the very beginning. I cut out a little styrofoam fish. I taped 2 straws together. Here's the minnow, here are the sharks, and this is how it works. The fish food goes in here. The idea is you have to charge up the minnow straw, getting lots of extra negative charges on this, and I have to try to get some of the food to be attracted to the minnow without getting eaten by the sharks. As soon as the sharks touch the minnow, I'm out.
So this is a game you can play at home. You can do it yourselves. Okay, so attention, you only need a kind of a basket, plastic basket. You have here a straw, okay, a thread, and these are very tiny particles of paper, and you have to put these particles here, in here, and then this straw is a plastic straw. You have to wrap up this plastic straw, so to get it positively or negatively charged. Attention.
Let's see if we can do this and reach in. He got me. Let's try over here. He got me. Reach in this way. Static electricity. Could actually be a fun game. Sharks and Minnows. Sharks and Minnows was a game we created using static electricity. Can you create your own game using static electricity? What if instead of tissue paper sharks, what if I hung up soda cans? I don't know, give it a try. Science is so cool. If you want to learn more about static electricity, check out our links in the video description. Thanks for watching.
Okay, thank you. And now, please, we're going to go back to our notes. It's so you have to go to your exercise part. We need to correct some exercises, and I need your contribution here, your help. So we're going to read it and be attentive. Number 7. So these sentences are about atoms and electricity, and you have to say true or false. So number one, millions of atoms can fit on the tip of a needle. What do you think? Is that true or false? What do you think? Waiting for you. So millions of atoms can fit on the tip of a needle. Podemos encontrar millones de átomos en la punta de un alfiler. What do you think? What do you think? Inés says true. And the rest? Julia, very good. Very good. Candela. Ah, very good. So this is true. Now, let's go to the next. So protons and neutrons are held together in the shells of an atom. Protons and neutrons. And it says that in the shells of an atom. What do you think? Is that true or false? Protons and neutrons are together. But are they in the cells or in the nucleus? What do you think? An atom is composed of two parts. The shells is the outside part, and the nucleus that is in the inside. So according to that, Candela says false, and Echo says false. Yes, this is false. So protons and neutrons are held together not in the cells, but in the nucleus of an atom. So this is false. Number 3. The number of electrons and protons are equal in an atom, which makes the atoms neutral. So chargeless, neutral. Forget about this last phrase. The number of electrons and protons are equal in an atom, which makes the atoms neutral. What do you think? Is that true or false? What do you think? Ines says true. Not very sure. And Sandra says false. Julia true. Remember, all matter needs to be neutral. Okay, so all matter needs to be neutral, and that is the reason why the number of electrons and protons have to be equal in an atom, which makes this sentence true. Very good. Now, number 4. Electricity travels near the speed of light, which is about 300,000 kilometers per second. What do you think? Is that true? What do you think? This is not easy. What do you think? Is that true? Number 4. The speed of electricity near the light speed. What do you think? Number 4. Do you think it's false? This is false, okay, because nothing travels at the same speed as light. So electricity is very fast, but not as fast as the the speed of light. So number 5, go here. So objects with the same electrical charge are attracted to each other. What do you think? Same electrical charge are attracted. Is that true or false? Number 5. Objects with the same electrical charge, same like charges, are attracted. Are attracted or repelled? What do you think? Number 5. Waiting for you. What do you think? Objects that have the same electrical charge are attracted or they repel themselves? Thank you, Candela. Thank you, Julia. Thank you, Miguel, Manuela. Very good. They repel. This is false. Objects with the same electrical charge repel each other. Very good. Now, number 6. Electricity. This is interesting. Electricity is the flow of protons. What do you think? Electricity is the flow of protons, the flow of neutrons, or the flow of electrons? What do you think? Electricity. Is electricity the flow of protons or the flow of electrons? What do you think? What do you think? Candela is really active this morning. Thank you, Candela. Candela says that this is false, but I'm not very sure. What do you think? What do you think? Electricity is? Thank you, Eneko. Thank you. Thank you. Electricity is not the flow of protons. It's the flow of electrons. Good, good. Number 7. When electrons move from a place to another, they carry electrical energy. Now, your opinion. What do you think? When electrons move from a place to another, they carry electrical energy. And this is? What do you think? What do you think? Number 7. When electrons move from a place to another, they carry electrical energy. Is that true or false? Is that true or false? Sandra says true. Candela says false. And the rest, I'm waiting for you. When electrons move from a place to another, they carry electrical energy, which is true, Candela. This is true. Why? Because electricity is the flow of electrons, so they carry the energy. Very good. So this is true. Number 8. Electricity is a form of energy that cannot be stored. What do you think? No podemos guardar electricidad. What do you think? Number 8. Can electricity be stored? What do you think? Number 8. What do you think? Number 8. Electricity. Waiting for you. You got to be more active. Yes, electricity. No. So this is false. Electricity can be stored. That's why we have batteries. Okay. Very good. Number 9. This is difficult. Benjamin Franklin was the first to prove that lightning, this is a mistake of mine, spelling mistake, lightning is one form of electricity. What do you think? Was Benjamin Franklin the first to prove that? Or there were two different scientists? One of them a German scientist from the 18th century. What do you think? No. Benjamin Franklin was a very interesting inventor and a good scientist, and he proved many things about lightning, but that was discovered before Benjamin Franklin. Very good. And now, finally, the first power plant to produce electricity was made by Thomas Edison in 1882 at New York City. Remember the text before? Thomas Edison, a very interesting, a prominent inventor. You think that is that true? You think? And in essence, true? Yes, it is. Yes, it is. Very good. And you have here another experiment, and you have here some questions about that. Remember, when you are combing your hair, static electricity can be produced. Why? Because when you are combing your hair with this comb, this plastic comb, you are rubbing your hair, and your hair is rubbing the plastic, and that produces static electricity. And you have here some questions. The first one is, why does the text say that static electricity is the stored form of electricity? And the question is answered by the keyword because we can keep away some electrons from the comb. Yes. But 2. A charge imbalance. What's the meaning of this expression? Remember, equilibrium is balance. Imbalance is the opposite. A charge imbalance, the meaning of this expression is that you have more positive charges than negative, or the other way around. So there are not equal number of positive and negative charges. This is the meaning of this expression. Now, number 3. Why is your hair attracted to the comb when you bring it near your hair? Why is it? Why? Why is it? And the answer is because your hair gets positively or negatively charged, and the opposite happens to your comb. Now look at the part 2 of the picture. Why are these tiny pieces of paper going up to the comb, jumping up? Can you see here? Can you see here? You remember the last demonstration in the video clip? And the reason is because this comb, after having combed this hair, is positively or negatively charged, and that's the reason why these tiny pieces of paper are attracted to the comb. Good, very good. And finally, what has a lightning bolt to do with electricity? And the answer is because when you have some clouds there in the sky, they are rubbing each other, and they are getting positively or negatively charged, and the Earth is neutral, so the Earth attracts the positive or the negative charges. So that's the reason why. And I like before ending this class, I like you to watch to some other video clip, and now pay attention to it. Pay attention to it. Oh, yes. Sorry,
the electrons within the wire
Sorry.
move towards the about electricity. Visualize a different world where you couldn't turn on a light, a computer, or even use the electric kettle to make your favorite hot chocolate drink. We use electricity constantly in our daily lives. It is one of our most important types of energy and power that we use. Its uses range from small batteries that operate your remote control car to huge motors that power ships and trains. Electricity operates our lights, runs our refrigerators, kitchen appliances, and powers motors. So electricity is very much important to all of us.
So electricity, we use electricity all our lives. Okay, so electricity is around us. We need electricity to live.
It takes a lot of work to generate this magical thing called electricity. Let's first learn the most popular way to generate electricity. How to make electricity. We get the electricity by simply changing other forms of energy.
Okay, so electricity, remember, is a form of electricity, energy, and we can make electricity by doing other things. This is coal, and this coal has chemical energy, and you have here fire, that is heat energy. With coal and this fire, you can produce steam, and you can turn this steam turbine, and you can generate electricity. You're going to see that.
For example, we can burn coal or many other fuels which diverts chemical energy into thermal energy or heat energy.
You remember that energy can't be made or destroyed, but we can change one form of energy into another. So here we have chemical energy. Remember that? Here, this fire means that we have heat energy, and we are turning this chemical energy and this heat energy into another kind of energy, kinetic energy. And this kinetic energy can be turned into electricity there.
Heat energy will cause water to heat sufficiently and move in a tank. Energy of motion is kinetic energy. The kinetic energy in moving water causes a turbine to turn a generator. A generator changes kinetic energy of a spinning wire or coiled wire to electrical energy.
So remember, here we have chemical energy. Then here we have heat energy. Then we have kinetic energy. And then finally we have electric energy. So electricity can be made. How? By changing other forms of energy into electricity. Oh.
The wire is surrounded on both sides by a very strong magnet. On one side, the negative side of the magnet is facing the wire. On the other side,
Remember, this is the negative side of the wire. This is the positive side of the wire. You remember that these are electrons. Electrons are tiny particles that are negatively charged, and they go here, down here.
the positive side of the magnet is facing the wire. Electrons within the wire are attracted to the north part of the magnet and will push away from the south part of the magnet. By spinning the wire, it continuously passes by the two opposite charges of magnetism. The electrons within the wire move towards the positive magnet end and away from the negative magnet end. We see uses of this electricity in our homes and schools. Now let's remember the definition of electricity. Electricity is a type of energy that can build up in one place
So we
or
can
flow
make
from one place
we
to
can
another
make
place.
electricity.
There are two types of electricity, static and current.
Remember, we're studying static electricity. So from now on, we're going to study current electricity. Two types of electricity: static and current electricity. What we are seeing today, studying, is static electricity. So from now on, we're going to study current electricity.
Let's study about these one by one. Static electricity. When electricity gathers in one place, it is called static electricity. For example, when you rub your feet on a carpet and then zap something when you touch it, it is static electricity that you have built up on the surface of your skin, discharging onto another object. Lightning is also a powerful
This is lightning. Remember, this is static electricity. These are clouds. They are rubbing to each other, and that generates an imbalance in charge. And that produces this lightning bolt.
Example of static electricity. Current electricity. Electricity that moves from one place to another place is known as current electricity. Examples of current electricity are starting a motorbike, turning on a light, watching TV, playing video games, charging a cell phone, and many more. Do you remember whenever you visit the local grocery shop, they use weighing machines to measure the weight? Do you have any idea how electricity is measured?
We can measure electricity because we're talking about science, and science is about all things that are composed of matter and can be measured. So we can measure electricity.
Oh, no, it cannot be measured like that. We can measure electricity in a number of ways, but few of them are particularly important. Voltage. The voltage is a type of electrical force that makes electricity run through a wire, and we measure this in volts. The greater the voltage, the more current will tend to flow. Volt is an electrical unit of voltage that is represented by the symbol V. Current. Voltage itself does not go anywhere. What moves through the electrical wire in a circuit is an electrical current. It is a steady flow of electrons that is measured.
Remember, a steady flow of electrons, this is electricity, and can be measured in other units, amperes.
In amperes or amps. Power. Together, voltage and current provides us electrical power. The bigger the voltage and the bigger the current, the more electrical power we have. We measure electrical power in units called watts. Now, we are all impressed with various uses of electricity, but it is dangerous as well. It sounds so scary, and it is. If you remember the safety rules, you can use electricity without getting hurt. Below is some safety rules before using anything related to electricity.
And that's important for you, okay? So, because electricity can be a very dangerous thing. So, pay attention now.
Don't plug a lot of stuff into a single extension cord.
Attention, don't plug a lot of stuff into a single extension cord. No enchuféis muchas cosas en el mismo enchufe.
Always fly your kite away from.
Si te gusta jugar con cometas, ponlas lejos de los cables de la luz. Attention, why? Because here you have a steady flow of electrons flowing. This kite can cut this, and you can get these electrons, and this is very dangerous.
Power lines. Keeping electrical.
Attention, you know that water could be a conductor of electricity. So, pay attention because you can't have something that is wet near a socket. Attention with that.
Things far away from water. Do not climb a tree near.
Don't climb a tree near power lines. Why? Because it can be a discharge. You can get hurt.
Power lines. Always wear unwet slippers before touching.
Why? Because these flip-flops are made of plastic or rubber, and rubber is an insulator. So, please always wear wet slippers before touching any electrical equipment.
Any electrical equipment. Stay away from broken or fallen power lines. Always ask your parents' help before touching electrical equipment. I hope now you know much about electricity. Be careful while using electricity and be kind to one another. Thanks for watching. Bye-bye.
Okay, bye-bye. Very good. Now that's the end of our class. And I hope you like it. And now we are meeting at 12 o'clock about maths. Thank you. Thank you to you all. And I want to cut that.